Have you ever looked up at the stars and wondered if we are alone in the universe? This simple yet profound question has fueled human curiosity and imagination for centuries. Since the dawn of civilization, we've been gazing up at the night sky, contemplating the mysteries it holds and dreaming of the possibility of life beyond our earthly confines. The allure of extraterrestrial life has permeated our culture, our science, and our hopes for the future. It has led us to formulate theories, construct sophisticated technologies, and embark on ambitious space missions. One such theory that has shaped our understanding of the cosmos is the Drake equation. Formulated in 1961 by astronomer Frank Drake, this equation provides a mathematical framework for estimating the potential number of communicative civilizations in our galaxy. It takes into account factors such as the rate of star formation, the fraction of stars hosting planetary systems, and the likelihood of life emerging on those planets. The Drake equation, while speculative, has provided the scientific community with a roadmap for our quest to find extraterrestrial life. In the same vein, the search for extraterrestrial intelligence, or SETI, was born. SETI's main goal is to detect signals that may originate from advanced extraterrestrial civilizations. By scanning the cosmos for radio, optical, or other potentially artificial transmissions, SETI endeavors to find evidence that we're not alone in the universe. The fascination with finding life beyond Earth has always been a part of our collective consciousness. However, it wasn't until the advent of modern technology that we could start to look beyond our own celestial neighborhood. With the development of powerful telescopes and space probes, we've been able to delve deeper into the cosmos, broadening our search for extraterrestrial life. As technology advanced, so did our ability to look deeper into the cosmos, leading us to the discovery of exoplanets. The existence of these planets orbiting stars outside our solar system has opened up a new frontier in our quest for cosmic companions. Stay tuned as we delve into the fascinating world of exoplanets in the next scene. Our search for cosmic companionship took a huge leap forward with the discovery of exoplanets. These celestial bodies, defined as planets orbiting stars beyond our own solar system, became beacons of hope in our quest to find life beyond Earth. As more and more exoplanets came into our purview, the concept of the habitable zone emerged, guiding our search for potential life-supporting environments. What exactly is this habitable zone, you might ask? Well, it's often referred to as the Goldilocks zone, a region around a star where conditions are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And why is this important? Because as far as we know, water is a fundamental ingredient for life as we understand it. Now, how do we go about finding these exoplanets and determining whether they fall within their star's habitable zone? Enter stage, NASA's Kepler and Transiting Exoplanet Survey Satellite, or TESS for short. These space-based telescopes have been instrumental in the discovery and cataloguing of exoplanets. Launched in 2009, Kepler mission's primary aim was to answer one simple question: how common are planets around other stars? And it did so spectacularly, identifying over 2,000 confirmed exoplanets during its 9-year lifespan. These discoveries included rocky Earth-like planets and gaseous giants, some of which reside comfortably within their star's habitable zone. On the other hand, TESS, launched in 2018, took over the mantle from Kepler with a wider field of view, scanning an area of the sky 400 times larger than that covered by Kepler. Its mission, to find exoplanets around the brightest stars in the sky, those closest to Earth, and identify those that could potentially support life. The discovery of exoplanets and the ongoing missions to catalogue them are expanding our understanding of the universe and our place in it. They are fueling our hopes and dreams of finding life beyond Earth, showing us that we are not alone in this vast cosmic playground. While exoplanets have opened up a universe of possibilities, we have also been looking closer to home. Mars, our cosmic neighbor, has been at the center of our search for extraterrestrial life. Mars, the fourth rock from the Sun, has long tantalized us with its potential for life. Its relative proximity and similarities to Earth make it a prime candidate in our celestial neighborhood. Over the years, our exploration of the red planet has been spearheaded by a series of robotic emissaries. The Mars rovers with names like Spirit, Opportunity, and most recently, Perseverance, have been our eyes and hands on the Martian surface. They've climbed craters, drilled rocks, and captured thousands of images, painting a picture of a world both familiar and alien. These rovers are more than just machines. They are mobile laboratories investigating the Martian environment. They search for signs of past or present life, exploring the geology and climate of Mars and paving the way for future human exploration. One of the most ambitious endeavors on the horizon is the Mars Sample Return Mission. This mission aims to bring back Martian rocks and soil to Earth for detailed analysis. The goal? To find signs of past or present microbial life on Mars. These samples could hold the answers to whether life ever existed beyond our pale blue dot. But what signs are we looking for? The answer lies in potential biosignatures, indicators of life. These could be in the form of organic molecules, traces of metabolic activity, or even fossilized microorganisms. The discovery of these biosignatures on Mars would be a paradigm-shifting revelation. The exploration of Mars is an epic tale of human curiosity and ingenuity. Each mission, each discovery, brings us one step closer to answering one of the most profound questions. Are we alone in the universe? But Mars isn't the only celestial body in our solar system that could potentially host life. As we continue our cosmic journey, we'll delve into the icy moons of Jupiter and Saturn, where subsurface oceans could harbor life forms beyond our wildest imaginations. So, stay tuned as we navigate the quest for our cosmic companions. Beneath the icy crusts of certain moons, there lurk vast oceans that could potentially harbor life. In the swirling dances of our solar system, two celestial bodies particularly pique our curiosity. Europa, orbiting Jupiter, and Enceladus, a satellite of Saturn. These moons cradle subsurface oceans beneath their icy veneers, a tantalizing possibility for the existence of extraterrestrial life. These subsurface oceans, insulated from the harshness of space, could provide an environment conducive to life, much like the deep volcanic vents in our own Earth's oceans. The intrigue of these distant moons has not escaped the attention of space agencies. NASA, for instance, is preparing the Europa Clipper mission. This ambitious endeavor will send a spacecraft to investigate the icy moon's secrets, including the depth and salinity of its ocean and the thickness of its icy shell. The quest for extraterrestrial life is not limited to far-off exoplanets or neighboring Mars. It extends to the mysterious oceans beneath the icy surfaces of distant moons. While we're exploring moons and planets, we're also looking to the skies for more direct signs of life. The gases in a planet's atmosphere could hold the key to discovering extraterrestrial life. Scientists across the globe are on a quest to find biosignatures, unique indicators of life in the atmospheres of exoplanets. They're like cosmic detectives, searching for traces of gases such as oxygen and methane. These gases, if detected in the right quantities and combinations, could suggest the presence of biological activity on these distant worlds. The James Webb Space Telescope, set to be the premier observatory of the next decade, promises to revolutionize our understanding of these atmospheres. It's not just a telescope, it's a time machine peering back into the early universe, but also scrutinizing the atmospheres of distant exoplanets, bringing us closer to answering the age-old question, are we alone in the universe? But despite our best efforts and advancements, we still face a puzzling paradox. With so many potentially habitable planets, why haven't we found any signs of extraterrestrial life yet? This question brings us to the Fermi paradox, a conundrum that has puzzled scientists and stargazers alike. Named after the physicist Enrico Fermi, the paradox presents an intriguing contradiction. On one hand, we have the Drake equation, suggesting a high probability of extraterrestrial civilizations in our vast galaxy. But on the other hand, we're confronted by a profound silence, the absence of observable evidence of such civilizations. So what gives? Well, there are numerous theories and speculations that attempt to explain this cosmic silence. One possibility is that we might just be looking in the wrong way. Maybe advanced civilizations are communicating using technologies that are beyond our current understanding or detection capabilities. Another theory points to the so-called Great Filter. This hypothetical concept suggests that at some stage in their evolution, civilizations encounter a catastrophic event or a series of challenges so severe that they either self-destruct or are unable to continue their technological advancement. If this is true, it could explain why we haven't heard from advanced extraterrestrial civilizations. Perhaps they simply didn't survive to reach a level of technological sophistication necessary for interstellar communication. Then there's the zoo hypothesis, which proposes that advanced civilizations are aware of us, but are intentionally avoiding contact, much like zookeepers with animals in a zoo. It's a humbling thought, isn't it? These theories, as fascinating as they are, remain speculations in the face of the great silence, but they serve a purpose. They remind us that the search for extraterrestrial life isn't just about finding aliens. It's about understanding our place in the cosmos, about pushing the boundaries of our knowledge, about asking questions that may never find answers. The search for extraterrestrial life continues to be a thrilling journey, full of challenges, discoveries, and unanswered questions. But one thing is certain: we're not stopping anytime soon.